Hey guys! Today we're going to be talking about sets and subsets and how they relate to rational numbers. Please have your journals ready to go to copy down some notes. First, please copy this objective above your Cornell notes at the top. I will use visual representation to describe relationships between sets of rational numbers. I'll give you a minute to copy that down. Okay, now we will begin. Whenever you're taking your notes, be sure to take your notes on the right side of your page, Cornell note style. The first thing I want to give you are two vocabulary words to get you familiar. The first word is going to be a set. A set is a collection of distinct objects. The second word is subset, part of a larger group of related things. A subset is a part of a set. So to give you a better understanding of how these two words relate to each other, we'll talk about a set that you will be familiar with. Let's say dogs. That is its own set. Within the category of dogs, we have all different kinds of subsets. We have poodles. We have German shepherds. We have pit bulls. These are just a couple of examples. So dogs would be the set. All of the different kinds would be the subset. Okay, so in your journals, in your notes section, I'd like you to draw this diagram with me. You're going to draw a large circle. This circle represents This circle represents the real number system. For today's lesson, obviously, we're not going to be talking about dogs. The set that we're talking about today is the real number system. That is our set. If you want to label it, go ahead. I always like to label things so that I know when I go back to study what exactly that was. Okay, so within the set of real numbers, we have different categories. The first category is going to be rational numbers. There's also another little category over here for irrational numbers, but we are not getting into it in this class, so don't worry about it. Within the set of rational numbers, we have integers. And within the set of integers, we have whole numbers. All right, most of you know what these are, but we're just going to give you a couple examples just to make sure. Whole numbers. That's going to be anything that is a whole number. It could be 4. It could be 40. It could be 50,000. It doesn't matter as long as it's a whole number. Integers. Integers are also whole numbers. So we have 4, 40, 50,000, and so on. But we also add in our negatives here. So we also have -4, -40. So our integers are any whole number, positive or negative. Positive or negative whole numbers. And then we have our rational numbers. This is just where everything else falls. So of course, 4 and 40 are rational numbers as well as whole numbers. -4 and -40 are also rational numbers, but they are also integers. And then we have everything that's left over. So all of our fractions, 3/4, all of our decimals, 0.75, anything that can be converted into a fraction is a rational number. Look at the front part of rational. It says ratio. A ratio is a fraction. So that kind of gives you a hint right there in the word. All right, so there was a couple of examples for you from each category. Now I want to kind of explain how this graphic organizer works. So something interesting that I always say to keep track is a whole number is always an integer, but an integer is not always a whole number. So let's think about that. A whole number is always an integer. So we have our 4, our 40, our 50,000. All of those are also integers. But the second part of the saying says not all integers are whole numbers. So not all integers are whole numbers. So our negatives are not our whole numbers. So all whole numbers are integers. All integers are rational numbers. And all rational numbers fall within this real number system. So if you can see the progression from the middle up, it's really easy to read and it's a great diagram to refer to. That is all I have for you today. We'll talk about it more in class. Way to go, first video. I'm out.